Namaste and welcome back to JEE Physics with Typical Monk. This is class 12, Thermodynamics. And the simplest way to hold this whole chapter in your head is this. Thermodynamics is energy bookkeeping. Heat flows into a gas. The gas pushes outward and does work. And its internal energy rises or falls to make up the difference. But the ledger always balances. Energy is never lost. Only move between these three accounts. Today, we make heat and work calculable. Through the first law, through the four processes a gas can follow, and through the engines that turn heat into motion, one idea at a time. Here is what you will learn today. First, the first law. Delta U equals Q minus W, and internal energy as a state function. Second, work is the area under a PV curve and the four processes. Third, the adiabatic relation PV to the power gamma is constant, and the molar heat capacities Cp and Cv. Fourth, cyclic processes, where the work is the enclosed loop area. And fifth, the second law, the Carnot engine, its efficiency, and the refrigerator's coefficient of performance, one idea at a time. 4 ideas. Run this entire chapter. Look at them together first. The first law, heat in minus the work done by the gas, equals the rise in internal energy. Delta U equals Q minus W. Energy is conserved, nothing vanishes. Work equals area. The work done in any process is the area under its curve on the PV diagram. The path matters, not just the endpoints. The four processes, isothermal, adiabatic, isobaric, and isochoric. Each one is a different curve on the pressure-volume plane. And internal energy depends on temperature alone. For an ideal gas, U is set by the temperature only, never by the path taken. That single fact makes delta U a state function. Now look at the gallery. All four processes drawn from one common starting point, A, on the pressure-volume plane. The isobaric process, pressure constant, is a horizontal line. The work is simply P times delta V, the plane rectangle of area beneath it. The isochoric process, volume constant, is a vertical line. No area is swept, so the work is zero, and all the heat becomes internal energy. The isothermal process, temperature constant, follows PV equals constant. Since the temperature does not change, delta U is zero, and the heat equals the work entirely. And the adiabatic process, no heat, Q equals 0, follows PV to the power gamma is constant. It is a steeper curve than the isomol, and here delta U equals minus W. Now let us apply the first law to each process in turn. Heat in equals the change in internal energy, plus the work done by the gas. Isothermal, the temperature is constant, so delta U is 0. All of the heat becomes work. Q equals WW. This happens slowly in contact with a heat reservoir. Adiabatic, no heat, so delta U equals minus W bar. The gas does work at the cost of its own internal energy, and so it cools. And it follows PV to the power gamma equals constant. Isobaric, pressure constant, so the work is P times delta V. The heat splits, part raises the temperature, part does work, and Q equals NCP delta T. Isochoric, volume constant, so the work is 0. All the heat becomes internal energy. Q equals delta U equals NCB delta T. 4 processes, 1 law, 4 special cases. Let us work one numerical all the way through. An engine running in a cycle. Per cycle, it takes in 500 joules of heat from the hot reservoir and rejects 300 joules to the cold one. Find the net work and the efficiency. The cycle rule first. Over one full cycle, the gas returns to exactly where it started, so delta U is 0. Internal energy is a state function. Apply the first law. With delta U equal to 0, the work equals the net heat. W equals Q hot minus Q cold. The net work, 500 minus 300, is 200 joules done by the gas per cycle, and that is exactly the area enclosed by the loop. The efficiency. Efficiency is the workout over the heat in 200 over 500, which is 0.4 or 40%. So the answer, the engine does 200 joules at 40% efficiency. And for any cycle, the work is Q hot minus Q cold, and the efficiency is 1 minus Q cold over Q hot. Now, the most efficient cycle there can possibly be the Carnot cycle. Look at the loop on the PV diagram. It is built from 2 isotherms and 2 adiabats. Heat enters along the hot isotherm at temperature T hot and leaves along the cold one at T cold. The work is the enclosed area. The net work done per cycle is exactly the area the loop encloses on the pressure volume plane. The efficiency eta equals 1 minus T cold over T hot with the temperatures in Kelvin. Notice it depends only on the 2 reservoir temperatures, nothing else. And this is the ceiling. No engine working between the same 2 temperatures can ever beat the Carnot efficiency. It is the absolute limit set by the second law. Now what JEE actually asks. 5 pointers. 1. Delta U equals Q minus W, and delta U depends only on the change in temperature. It is path independent. Q and W are not. 2. For an adiabatic process, PV to the power gamma is constant, and TV to the power gamma minus 1 is constant. The work is P1V1 minus P2V2 all over gamma minus 1. 3. Mayer's relation Cp minus Cv equals R, and gamma is Cp over Cv 5/3 for a monatomic gas, 7/5 for a diatomic. 4. The Carnot efficiency eta equals 1 minus T cold over T hot. In Kelvin, the ceiling no real engine beats. And 5. The refrigerator's coefficient of performance is Q cold over W, which equals T cold over T hot minus T cold, and unlike efficiency, it can be greater than 1. Now, an assertion and reason drill. For each pair, decide are both true, and does the reason explain the assertion? First pair. Assertion. In an isothermal process, the internal energy of an ideal gas does not change. Reason. The internal energy of an ideal gas depends only on its temperature. Both are true, and the reason directly explains the assertion. So the answer is A. Second pair. Assertion. An adiabatic curve is steeper than an isothermal through the same point. Reason. In an adiabatic process, no heat is exchanged with the surroundings. Both are true, but the steepness comes from the gamma factor, not merely from the absence of heat, so the reason does not explain it. The answer is B. Third pair. Assertion. A Carnot engine can be made 100% efficient. Reason. The efficiency, 1 minus T cold over T hot, reaches 1 only when the cold reservoir is at 0 Kelvin, which is unattainable. The assertion is false. The reason is true, so the answer is D. Now match each process to its condition. Isothermal goes to delta U equals 0 and Q equals W. Adiabatic goes to Q equals 0 and PV to the power gamma is constant. Isobaric work goes to W equals P times delta V. And the Carnot efficiency goes to 1 minus T cold over T hot. 4 pairs, and every one of them is worth committing to memory. Now, how many of these 3 statements are correct? 1. In a cyclic process, the net change in internal energy is 0. That is correct. The gas returns to its start. 2. In an adiabatic process, the gas exchanges heat with its surroundings. That is wrong. Adiabatic means Q equals 0. No heat is exchanged at all. 3. For an ideal gas, Cp is always greater than Cv. That is correct. The extra heat at constant pressure goes into the work of expansion. So the answer 2 are correct. Statements 1 and 3. The trap is statement 2. Adiabatic is precisely the no heat process. Now the 2 mistakes that quietly cost marks. The myth. The change in internal energy depends on the path taken between 2 states. The truth. Delta U depends only on the endpoints. It is a state function. Only the heat Q and the work W are path dependent, never the internal energy. The second myth, isothermal and adiabatic expansions between the same two volumes do the same work. The truth, they differ. The adiabatic curve is steeper, so it does less work. You must use each process's own formula, never one for the other. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. 100 joules of heat is added, and the gas does 40 joules of work. Find delta U, Q minus W, 100 minus 40 is 60 joules. Question 2. The work done in an isochoric process. Volume is constant, so the work is 0. Question 3. A Carnot engine between 600 Kelvin and 300 Kelvin. 1 minus 300 over 600, that is 50%. Question 4. Gamma, which is Cp over Cv, for a monatomic ideal gas, 5/3. And question 5. Cp minus Cv for 1 mole of an ideal gas, that is R, the gas constant. Constant is Boston, Nassing, Scrade. Let us gather it all in one breath. The first law, delta U equals Q minus W. Internal energy is a state function set by the change in temperature alone. The 4 processes is thermal, where delta U is 0, adiabatic, where Q is 0 and PV to the power gamma is constant, isobaric, where the work is P delta V, and isochoric, where the work is 0. Work is the area under the PV curve, and over a cycle, the work equals Q hot minus Q cold, the enclosed area. Cp minus Cv equals R, gamma is Cp over Cv, and the adiabatic work is P1V1 minus P2V2 over gamma minus 1. And the second law, the Carnot efficiency, 1 minus T cold over T hot, is the ceiling. The refrigerator's coefficient of performance is T cold over T hot minus T cold. Next class, simple harmonic motion and oscillations, the motion, the energy, and the pendulum. Heat and work are no longer a mystery. The ledger always balances, and with the first law, the 4 processes, and the Carnot ceiling, you can now put a number on any engine. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.